Hello everyone. Today we are going to run the chapter 12, the basic of capital budgeting. We also call this investment decision. In the previous lecture I showed some overview of corporate finance. So today's lecture is here, right? The investment decision. So it is about the budget capital to good project. So we will learn some tools, for example NPV or IRR. Capital budgeting. The capital budgeting is regarding long-term investment decision. What is needed to investment? The capital, the money, right? So it involves large expenditure. So it's very important to plan the future. Now we are going to run some tools for evaluate project value and decide whether we will proceed or not. Slide shows the tools for evaluate the project. The payback period, the discounted payback period, NPV. NPV stands for net present value, and IRR, internal rate of return, and modified IRR. So let's learn more deeply at the next slide. Method is payback period. The payback period means the number of years required to recover project cost. So payback period represents how long does it take to get the money back. So it calculated by adding project cash inflows to each cost until the cumulative cash flow for the project turns positive. So let's run with the example. First, come up with the timeline of the project. So for example, the 0, 1, 2, and we have many years and n. And cash flow at 0, cash flow at 1, cash flow at 2, cash flow and tilde, right? And as you can see, cash flow at 0 here, right? Mostly it has negative number. What does it mean? Yeah, that is the initial cost of firm. For example, to build a factory or buy a new machines. Investment decision, the investment means what? The investing in physical asset, right? So at the current time, there is some cash outflow. And during this period, yeah, I take a tilde, right? It means actually we estimating cash flow, but it is very difficult. So this stage we assume the cash flows are given number. So in the corporate finance course, we will learn how this cash flow is estimated. And T1 to T2, what are these cash flows mainly coming from? Yeah, the selling the product subtract by cost. And what does it mean N? N means the life of project. So in this case, life of project is 3, right? 3-year project. So when end of project, firm sell the fixed asset, that called salvage value. So there is some salvage value. Here, right? What is salvage value? Yeah, salvage value in Korean 잔존가치. So salvage value means that the fixed asset can still have some value at the end. So it has positive number, right? Let's assume we have two projects, the project L and one more project, the name is project S. And this project have a cash flow like this: 0, 1, 2, 3. Cash flow is minus 100, 70, 50, and 20. Calculate the project L's payback period. So these numbers, cash flow at T and minus 100, 10, 60, 80, that is given number, right? And cumulative number, yeah, it is calculated number. So minus 100, calculated number at T0, the minus 100 is same, right? And at T1, these two, sum of these two, right? And then get this number, and this number, sum of this, and get minus 30, right? And this number also summation of this, so we get 50, right? Through the payback period, when the cumulative cash flow turns positive, yeah, between 2 and 3 years, right? So we can calculate payback period as this. Payback period, this number is number of period prior to full recovery. And 30 means here, right? Unrecovered cost at start of period, and 80, it means cash flow during full recovery period. Let me explain again. The full recovery period is here, right? Year at 3. The cumulative cash flow is positive, turn to positive. So number of periods prior to full recovery is this number, right? 2. And plus we should calculate unrecovered cost at start of period. The start means just a full recovery. Full recovery starts between 2 and 3, right? So the unrecovered cost is a negative number, right? But we put positive number because we calculate the number of periods, right? So 30, and over we divide by some number that is cash flow during full recovery period. Yeah, it is here, not a 50. The cash flow during full recovery period 80, and then calculated this equation. Finally, you get 2.375 years. What does it mean, 2.375 years? Yeah, this numbers means how long does it take to get our money back. So project L, when they invest $100 at the current time, they can pay back this money after 2.375 years. And when you use this equation, you can also calculate project S payback period, and it is 1.6 years. And I can give you one question: which project is more good when you use payback period method? Project S or project L? Yeah, project S, right? The shorter payback, the greater project liquidity, right? So we can accept to invest in project S, and reject to invest in project R, right? Or we can choose not only one project, we can choose 2 or more projects. When you use payback period, there exists the strengths and weakness. The strength is it is easy to calculate and understand, and it provides an indication of a project risk in terms of liquidity. Especially it's good method for small firm because small firm don't have ready to access the capital market. However, the payback period have serious problem. Let's move back to previous slide. As we learned before at the time value of money chapter, the future money should be discount, right? But as you can see, these cash flows does not discount, right? So the weakness is does not consider time value of money. It means does not discount cash flows. That is weakness. Solve this problem. The payback period used discounted cash flows. So we call that the discounted payback period method. So as you can see, there is one more information, the discount rate, right? And we can calculate the present value of the cash flows, and this number can be calculated by 10 over discount rate, and also this number 61 plus discount rate and power of 2, right? Discount 2 times, and this number 81.1 power of 3, right? So now we calculated present value of cash flows and then calculate the cumulative cash flow, right? Sum of these two, we get this number, and repeat the process. We calculate all the cumulative cash flow. And discounted payback period, this number means what? The number of periods prior to full recovery. As you can see, between 2 years and 3 years, there is a full recovery, right? The cumulative cash flow turned to positive number. So that is 2, and this number is coming from the unrecovered cost at the start of period. Yeah, full recovery start. And this number is cash flow during full recovery period, right? And then we get the discounted payback period, 2.7 years. It means what? Yeah, if we invest this project, our money can get back after 2.7 years, right? But one more serious problem still exists in payback period method. Suppose that I change the project. Just think about there is additional cash flow at T4. So for L, let's assume there is cash flow of this amount. And for S, only 10. In this case, payback period method does not consider cash flow after T3, right? It does not consider this money. So when we use the payback period method, the project S is better even though project L is much better. after period 4 we can get more money, but according to the payback period methods, the project S is more liquidity project, right? So we cannot use payback period except company has liquidity problems. We can write one more weakness of the payback period, that is, it does not consider cash flows after that occur after the payback period. Yeah, that is conclusion of payback period method. Now we move to the second and third method. This is NPV and IRR. There are 3 steps. The first step is to estimate the cash flows, the inflows and outflows. And as I mentioned before, it is hard to estimate the future cash flows, right? So in this stage, it is just given number. And second, assess the riskiness of cash flows by determining the appropriate cost of capital. So this is the definition of the NPV, net present value. It can be calculated by sum of present values of all cash inflows and outflows of a project. As you can see, there is R, right? What does R mean? We already saw the number, the R. In this case, 10%. What does the number mean? Is that market interest rate? Then all firms use the same discount rate, right? But it's not fair. A discount rate should reflect the risk of company. So who take the risk? Who provide the capital? Investor, right? The investor require rate of return. So let's say 2 companies with a different risk. If the cash flow is very safe, the projecting number is very accurate. The opposite case, if firm invests in risky project, the projecting number is not accurate. Then investor require higher rate of return, right? There are 2 types of investors, the bondholder and stockholder. So put them cost of bond and cost of stock together, what we will get? Yes, the weighted average cost of capital, the WACC, right? So the 10%, it means the WACC. So when you calculate NPV, the discount rate is WACC. Example, the using discount rate and compute the present value of cash flow and add up, right? That is method of the NPV. So the discount rate is the WACC, right? So R is the WACC. It is 10%. So this number is coming from 10 over 1.1, right? And this number 10.1.1 power of 2, 10, 1.1 power of 3, right? And then you sum up these numbers, including at T0. Finally, you get NPV of project L, right? The $18.79, and you can also apply to project S. You get this number. You can also calculate NPV using Excel. So in Excel, the function name is NPV, and firstly you input the discount rate, the WACC, and you input cash flow at T1. Yeah, that is the tricky part. the cash flow at T1 and 60, 80, and then you input the cash flow at T0. Why? Yeah, it does not need the discount, right? So Excel function apply to from cash flow at T1. Cash flow at T0 you should add manually. Which project is more good? The project L or project S? What does it mean, this number? Yeah, this slide shows the rationale for the NPV method. So NPV method, it represents net gain in wealth. What does it mean, net gain in wealth? It means how much a project contribute to the shareholders' wealth. So we can interpret this, yeah, $19.98, this amount of money can be contributed to the shareholders' wealth. It is larger than project L, right? So NPVS is more good project. If we can choose as many projects as we want, we can say these projects are independent. In this case, we can offset if the project NPV larger than 0. Project L and project S both are larger than 0, right? So we can offset both. Offset both if independent. The second case, if the only one project can be chosen, we can call these projects are mutually exclusive. In this case, offset project with the highest positive NPV, those that add most value, right? Add most value to who? The shareholder, right? Shareholder's wealth. So as you can see, NPV of project S has more value than NPV of project L, right? So we accept S if the mutually exclusive case, right? Yeah, that is the conclusion of the NPV method. We run a new tool to evaluate the project, the IRR, internal rate of return. IRR is the discount rate that puts present value of inflows equal to cost and the NPV equal to 0. So do you remember the NPV general formula here, right? NPV can be calculated by sum of present value of all cash inflows and outflows of a project. Let me write again. NPV function can be written as this. NPV equation. The sigma t equal to 0 power of n and cash flow subscript t, and it should be discount with what? The WACC, right? Power t. That is general formula. Now you want to calculate the IRR. The IRR means the post present value of inflows equal to cost. So NPV is equal to 0. So NPV equal to 0, and then this equation change a little bit, CFT, and denominator is IRR. Yeah, it changed a little bit, right? NPV changed to 0 and WACC changed to IRR. What does it mean? IRR, it means the project's rate of return. The project rate of return. That is the IRR. This is a similar framework with the bond valuation, the yield to maturity. So this slide shows how is the project IRR similar to a bond yield to maturity. The NPV formula can be write as this. The NPV CF0 cash flow at 0, that is initial cost, right? And t equal to 1 to n means life for project, cash flow t 1 plus r power of t, right? We can separate the cash flow here and here, right? And IRR case, NPV goes to 0, and we can rewrite this equation. And the R is what? In this case, IRR, right? And this can be goes to left hand side, so minus CF0 is equal to t equal to 1 power of n cash flow t 1 plus IRR power of t, right? And think about a bond as a project. The yield to maturity on bond would be the IRR of the bond project. So let's with example. Suppose a 10-year bond with 9% annual coupon, and the par value is $1,000, and it sells for $1,134.20, right? And we can write the equation as this: 1.34.2, that is the value of bond here, right? And the coupon rate is 9%, so 90, and 1 plus R square. At the maturity, they get coupon and face value, right? And 1 plus R power of n. In this case, the power is 10, right? Yeah, power of 10. 10-year maturity bonds. And what is R? R represents what? Yeah, when we know the bond price, this R means yield to maturity, right? When we invest this bonds, we can expect this amount of return, right? One interesting, as you can see, this equation looks similar with this, right? The price of bonds is similar with initial cost, and the IRR looks similar with the yield to maturity. Yeah, let's highlight here and here, and IRR and yield to maturity here, right? Why? The yield to maturity is the discount rate that puts the present value of cash flow to equal the price of bonds, right? And IRR rate that puts the present value of cash flow to equal to the initial cost. Yeah, it is very similar concept, similar framework. So we can conclude that IRR represents project rate of return. The example of the project L and S, you can input the numbers here, then solving for IRR, you get some rate, right? You can write a full equation. Or the second method is using Excel. Using Excel, the function is IRR, and then you input all the cash flow at T0, cash flow at T1, cash flow at T2, cash flow at T3. Yeah, cash flow at T0, this is cash flow at T3. Then you get some number. 18%. This is project L's IRR. And project S IRR is 24%. Which project is more good? Project L or project S? Yeah, project S, right? The expected rate of return or the project rate of return is more higher in project S, and it has lower return in project L, right? In addition, there is decision rule about IRR. Do you remember what is decision rule about NPV? Yeah, NPV should larger than 0. IRR case, IRR should be larger than WACC. So our example, WACC was 10%, right? Both are larger than WACC. It means what? The project rate of return should be larger than weighted cost of capital. Rationale for the IRR method. So if the projects are independent, what does it mean? It means if we can choose as many projects as we want. So if the projects are independent, we can choose the project with IRR larger than WACC. And the second case, if the projects are mutually exclusive, it means what? Yeah, only one project can be chosen. So if the projects are mutually exclusive, to choose the project with higher IRR, and it should be larger than the WACC, right? Now we run 3 methods of capital budgeting: the payback period, and net present value, and internal rate of return. IRR have some problems, so we will learn that at the next lecture. And in addition, we will learn some additional method to evaluate the project. Thank you.